Boston, Massachusetts is one of the oldest cities in America, founded in 1630, more than a few years before the advent of modern motor vehicles. In the 1980s, traffic in downtown Boston was nearly unbearable from the tangled streets laid out centuries ago. So, city planners and state transportation officials came up with what they considered a grand plan. They would reroute the elevated highway and so-called central artery of Interstate 93 into a tunnel below downtown, and extend Interstate 90 across the Inner Harbor to the airport in another tunnel. Construction started in 1991, and the project was given the nickname Big Dig because of the sheer volume of excavation required for the two tunnels. In terms of cost and complexity, the Big Dig was on the scale of the Panama Canal or Hoover Dam. It featured some of the most innovative construction methods of the time, and after 16 years of work, the project was finished on time and under budget. Actually, no. You might know the story already. Of course, the Big Dig did make a big dent in the traffic problem in Boston, but that came at a staggering price. The project was plagued with problems, design flaws, fraud, delays, and of course, cost overruns. When construction finished in 2007, the final price tag was around $15 billion, about twice the original cost that was expected. It's a tale as old as civil engineering. A mega project is sold to the public as a grand solution to a serious problem. Planning and design get underway, permits issued, budgets allocated. That took a lot longer than expected. Construction starts, and then there are more problems. Work is delayed, expenses balloon, and when all the dust settles, it's a lot less clear whether the project's benefits were really worth the costs. Not many jobs go quite as awry as the Big Dig, but it's not just mega projects that suffer from our inability to accurately anticipate the expense and complexity of construction. From tiny home renovations to the largest infrastructure projects in the world, it seems like we almost always underestimate the costs. And the consequences of missing the mark can be enormous. Well, I've been one of those engineers trying to come up with cost estimates for major infrastructure projects, and I've been one of those engineers who underestimated. So I have a few ideas about why we so consistently get this wrong. I'm Grady, and this is Practical Engineering. In today's episode, we're trying to answer the question of why construction projects always seem to go over budget public funds. So it's important, it's vital, that the benefits we derive from them are worth the cost. And the only way we can judge if any project is worth starting is to have an accurate estimate of the costs first. And of course, this is not just a problem with civil infrastructure, but with all types of large projects paid for with public funds, like space programs and defense projects. They have to be justified. Most projects have benefits, and you do get those benefits at the end, no matter the cost. But if they aren't worth the cost, you'd rather not go through with the project at all. This is especially true for projects like streets and highways where not only the costs get underestimated, but the benefits are often overestimated too. Check out my friend Jason's videos on the Not Just Bikes channel for more information about that. One of the biggest issues we face with large projects is a chicken and egg problem. You don't know how much they'll cost until you go through the design, but you don't want to go through a lengthy and expensive design phase and end up with a project you can't afford. Budgeting and securing funds are usually slow processes, plus you need to know if the job's even worth doing in the first place. So you can't just wait until the bids come in to find out how much a project is going to cost. You need to know sooner than that, which usually means you need your design professional to estimate the costs. For an infrastructure project, that's the engineer, and engineers are notoriously not good at estimating costs. We don't know which contractors are busy and which ones aren't, what machinery they have, or whether or not they'll bid on your project. We don't know the sales reps at the concrete and asphalt plants, or keep track of the prices of steel, aggregates, pumps, and piping. We don't have a professional network full of subcontractors, material suppliers, and equipment rental companies. We didn't study construction cost estimating in college, and most of us have never built anything in the field. And the people who have, those who are most qualified to do this job, the contractors that will actually bid on the project, usually aren't allowed to participate in the cost estimating during design because it would spoil the fair and transparent procurement process. It would give one or more contractors a leg up on the competition. Because, here's a little secret, they aren't always so good at estimating costs either. When those bids come in, there's often a huge spread between them, meaning one of the most significant uncertainties of an entire project is sometimes simply which contractors will decide to bid the job. Of course, there are some alternatives to the normal bidding process that many infrastructure projects use, but even those often require early cost estimates from people who are necessarily limited in their ability to develop cost estimates. In fact, the industry term for the cost estimate that comes from an engineer is the opinion of probable construction cost, or OPCC. Take a look at that mouthful. 2 qualifiers, opinion of probable construction cost. And still, agencies and municipalities and DOTs will write that number down on a folded piece of paper, slide it surreptitiously to their governing board, and whisper, "This is how much we need." And the next day, the journalists who were at the meeting will publish that number in the news. And now every future prediction of the project's cost will be compared to that OPCC, no matter how early in the process it was developed. All this to say, estimating the cost of a construction project is hard work, especially early on in the project's life cycle. It takes highly skilled and knowledgeable people to do it well, and even then, it's a process absolutely chock full of uncertainties and risks that are really hard to distill down to a single dollar value. But construction cost estimates are just imprecise. If that were true, you would expect us to overestimate as frequently as we come under. And we know that's not the case. Why is it always an underestimate? One hint is the fact that you often just hear a single number for the project's cost. What's included in that $15 billion for the big dig or the cost estimate you see for a major project in the news? The truth is that it's different for every job, to the point where it's almost a meaningless number without further context. Large infrastructure projects are essentially huge collaborations between public and private organizations that span years and sometimes decades between planning, design, permitting, and construction, land acquisition, surveying, environmental permitting, legal services, engineering and design, and the administration to oversee that whole process all cost money, sometimes a lot of money. And that's before construction even starts. So if you think that a bid from a contractor is the project's cost, you're missing out on a lot. And if those pre-construction costs get included in one estimate, for example, the final tally of a project's cost, when they weren't included in an earlier estimate, like the engineer's OPCC, of course it's going to look like the project came in over budget. You're not comparing apples to apples. Another reason for underestimation is inflation. The main method we use to estimate how much something will cost is to look back at similar examples. We consult the ghost of construction past to try and predict the future. It's not unusual to look at the cost of projects 5 or 10 years old to try and guess the cost of a project 5 or 10 years into the future. The problem with that is dollars or euros or yen or pound sterling don't buy the same amount of stuff in the future that they did in the past. The cost of anything is a moving target, and it's usually moving up. That's okay, you might think. Just adjust the costs. There are even inflation calculators online, but they normally use the Consumer Price Index. That's a figure that tracks the cost of a basket of goods and services that a typical individual might buy. Prices vary widely across locations and types of goods, so the idea is that if you monitor the dollar price of groceries, electricity, clothing, gasoline, etc., it can give you a broad measure of how the value of money changes over time for a normal consumer. But there's not that much concrete and earthwork in that basket of goods, which means the Consumer Price Index is generally not a good measure of how construction costs change over time. There are a few price indices that track baskets full of labor hours, structural steel, lumber, and cement, and even separate those baskets by major city. You have to pay to get access to the data, and they can help a wayward engineer adjust past construction costs to the present day. But they can't help them predict how prices will change in the future. And that's important because large infrastructure projects take a long time to design, permit, and fund. So if there are 2 or 5 or 10 years between when an estimate was prepared and when it's being used or even discussed, there's a good chance that it's an underestimate, simply because the value of money itself slid out from underneath it. Cost estimates have an expiration date, a concept that gets overlooked, sometimes even by owners, and often by the media who report these numbers. That slow timescale for construction projects creates another way that costs go up. Designing a big project is like navigating a big ship. If things start moving in the wrong direction, the time to fix it is already past. So we don't do it all in one fell swoop. You have a bunch of milestones where you stop and check the progress, because going back to the drawing board is time-consuming and expensive. The issue with this process is that the further a project matures, the more people get involved. Once you've established feasibility, the bosses and bosses' bosses start to weigh in with their advice. Once you have a preliminary design, it gets sent out to regulators and permitting agencies. Once you have some nice renderings, you hold public meetings and get citizens involved. And with all those cooks in the kitchen participating in the design process, does the project get simpler and more straightforward? Almost never. There is no perfect project that makes everyone happy, so you end up making compromises and adding features to allay all the new stakeholders. This may seem like a bunch of added red tape, but it really is a good thing in a lot of ways. There was a time when major infrastructure projects didn't consider all the stakeholders or environmental impacts. And sure, the projects got done more quickly, efficiently, and at a lower cost on the surface, but the reality is that those costs just got externalized to populations of people who had little say in the process and to the environment. I'm not saying we're perfect now, but we're definitely more thoughtful about the impacts projects have, and we pay the cost for those impacts more directly than we used to. But often those costs weren't anticipated during the planning phase. They show up later in design when more people get involved, and that drives the total project cost upward. And the thing about project maturity is that even when you get to the end of design, the project still only exists as a set of drawings on a piece of paper. There are still so many unanswered questions, the biggest one being, how do we build this? Large projects are complex, putting them at the mercy of all kinds of problems that can crop up during construction. Material shortages, shipping delays, workforce issues, bad weather, and more. Then there are the unexpected site conditions. An engineer can only reasonably foresee so much while coming up with a design on paper or in computer software. A good example is the soil or rock conditions at the site. During design, we drill boreholes, take samples, and do tests on those samples. That lets you characterize the soil or rock in one tiny spot. Of course, you can drill a lot of holes, but those holes and those tests are expensive. So it's a guessing game, trying to balance the costs of site investigations with the consequences of mischaracterizing the underlying material. If the engineer guesses wrong, it can mean that excavation is more time-consuming because the contractor expected soil and got rock, or that backfill material has to be brought in from somewhere else because the stuff on site isn't any good. In the worst cases, projects have to be redesigned when the conditions at the site turn out to be different from what was assumed in the design phase. And that's just the dirt. While it might be great for science or history, imagine the cost of your project if you find historical artifacts or endangered species that you didn't know were there. It's a simple reality that there's a lot of uncertainty moving from design into construction, and there just aren't that many unexpected conditions that make a construction project simpler and cheaper. Of course, opportunities for cost savings do crop up from time to time, but usually those savings get pocketed by the contractor, not passed along to the owner. That's intentional, that the contractor takes on a lot of the risk, both good and bad. But you can't saddle a contractor with all the risk that something unexpected won't show up. And nearly all large contracts have change orders during construction that drive up the cost of the project. Of course, you can't ignore the more nefarious ways that costs go up. Any industry that has a lot of money moving around has to contend with fraud, and you don't have to look too hard through the news to find examples of greed. And there are also plenty of examples where politicians or officials misrepresented the expected cost of a project to avoid public scrutiny. But in most cases, the reasons for going over budget are much less villainous and far more human. We're just too darn optimistic and short-sighted. But that's not a good excuse, and I think there's a lot of room for improvement here. So what do? How can we get the actual project costs closer to the budget? Of course, we can bring construction costs down, but that's a whole discussion in and of itself. Maybe we'll table that topic for a future video. I can hear people screaming at the monitor to just add contingency to the budget. Anyone who's ever guesstimated the cost of anything knows to tack on an extra 15% for caution. Of course, contingency is a tool in the toolbox, but even that has to be justified. We know that the final cost of a project can be more than twice the preliminary estimates, but if you tell a client you added 100% to your estimate for safety, most likely you're going to get fired. No one wants to believe there's that much uncertainty, and also, it might not be true. You can't set aside $1 billion for a project that costs $100,000, give or take a few K. Sure, you'll come in under budget, but you just tied up a huge pile of public resources for no good reason. It turns out a lot of the research suggests spending more money during the planning and design phases. Of course, the paper-pushing engineer is saying to spend more money on engineering, but really, construction is where the majority of project costs are. So the theory is that if you can reduce the risks and uncertainty going into construction by spending a little more time in pre-construction, you'll often earn more than the cost back in the long run. Take 3 to 5% of those dollars you would have spent on construction and spend them on risk assessment and contingency planning and see if it doesn't pay off. Honestly, even most contractors would prefer this. I know their insurance carriers would. But all that considered, I think the biggest place for improvement in budgeting for large construction projects is simply how we communicate those budgets. A single dollar number is easy to understand and easy to compare to some future single dollar number, but really it's meaningless without more context about when it was developed and what it includes. Because what is a budget anyway? It's a way to manage expectations. And if you're early on in the planning or design phase of a big project, you should expect the unexpected. There's uncertainty in big projects, and it should be okay to admit that to the public. It should be okay to say we think it's going to cost X, but there's still a lot of unknowns, and we think the project will still be worth doing even if the cost climbs to Y. And if it goes beyond that, we're not just going to keep pressing on, we're going to regroup and find a way to make the benefits worth the cost. There is a ton of room to improve how we develop cost estimates for projects, but there's tons of room to improve how we communicate about them too. Let me show you another example of how costs aren't always as simple as they seem. $70 sounds pretty steep for a new razor, but if you do the math for the costs over time, at least for my situation, it's actually cheaper than using my old standby, the multi-blade cartridge. This video sponsor, Henson Shaving, reached out to me last year and asked to sponsor a video. I said, let me try the razor first and then I'll decide. That was 6 months ago, and I truly and honestly have not used my old razor once since then. Hey, is a new razor going to change your life? Probably not. But shaving's a chore, and using a precision tool, at least to me, makes it feel less like a chore, and instead a part of my day that I actually look forward to. I had never used a safety razor and figured they were old school. Not true. These are made in an aerospace machine shop that pivoted during the pandemic slowdown. I also figured it would have a learning curve. Also not true. In fact, I don't think I could ever go back to a cartridge razor with their flexible blades and difficulty in rinsing out. If you've ever been on the market for a tool and splurged on the nicest brand, this is that, except it's not really a splurge. The blades for the Henson razor are so cheap, you could probably put a new one on for every shave and still save money. And in fact, if you buy a razor, put the 100-pack of blades in your cart and use my code Practical Engineering at checkout, and those blades are on me. 100 blades is going to last you a long time. There's no subscription service or a monthly fee. It's just a cool razor that I really like, and I think you will too. Again, use my code Practical Engineering at checkout to support the channel and get 100 blades on me. Thank you for watching, and let me know what you think.